Hello, everybody. So tonight is more stuff about object-oriented programming. Mostly example night and a little shorter on the lecture side, so we can get started doing something. First thing on the agenda tonight is talk about the homework assignment here for this week, because it's not due for a couple weeks because we're stretching things out. But the first part, obviously, that's going to cover several chapters. So the first part, I would like you to go ahead and try to knock that out this weekend with what we've gone over in class so far, or equivalently the first of the 3 chapters, I think, in the textbook. But the equivalent of what we're going over in class, just the basic data sort of objects and using those. I guess we can start there. And then more stuff with examples. One that I meant to put in the example the other day and slipped my mind until after class. I think on the ride home or at some point over the last two days, I was like, oh yeah, I completely forgot to mention one of the other big times we use that keyword static. So we'll look at that. But first off, the homework assignment for this week, or this module, which I guess is due, what, 2 weeks from now? Maybe almost 3 weeks from now. It's not due till well into October, so we've still got a few days before it's due. But the first part on there, we're going to pull that up. The first part on there is what we're talking about the other night and are going to continue talking about tonight. So it wouldn't be a bad idea to go ahead and knock out that first part and help develop familiarity with this stuff before we move on to the more interesting things next week, or extend these things next week. Let's see, under modules, 16-week courses really stretch out. We're only in module 3 now. Oh yeah, it's not due till October 4th. So there's a pretty good chance I figure y'all probably wouldn't even look at it for a few more days still. But the first one, a class is a data type. One of the ways I described it the other day is it's a virtual representation of a real world object. So that's what I made the chapter 9 assignment. Instead of using any of the book to have those small exercises that are kind of like practice with algorithms. I want to just pure practice with creating objects, creating classes. So I ask you to, those other ones are just straight out of the book. There's still plenty of those types of exercises. But on the first one, pick a real world object that you might want to represent virtually. So you'll notice right off the bat, I mentioned the other day, pretty sure I mentioned it the other day, it's something I often say, that it was through game development that object-oriented programming really started to make more sense. But you'll notice I did not put game character on this list. So I did intentionally leave off game character. I want you to do a representation, an object representing a real world item. So like a gaming computer build. What data fields would you need to represent that? What methods would a virtual representation of a gaming computer have? If it helps, think about a retail site, like online retail. What data fields will you have to represent your object? What sort of things can it do for people to test out before they order it? Maybe if that helps to put it better. Come up with some real world object. From talking to some of y'all before, I started putting together a list with the roster. I was like, well, I know a couple people's hobbies, so I've jotted down a few things that I thought might be on there. If you have some other ideas, just run them by me, send me an email. It'll probably be okay. Just some real world object and make a class, make a Java object to represent that real world object. What data fields do you need? What methods would it have? When you override toString and equals, and we're going to look at comparable tonight. We'll throw that in there as well. So what does it mean when you hit print on that object? What is the string representation of it? What does it mean for 2 of them to be equal? or we're going to look at comparable tonight. So what does it mean for one of them to be greater or less than the other? Think about those things and how would you represent real world objects in the virtual format in Java, just to get some practice with object-oriented stuff. And for a couple of people on the roster, I know some hobbies and things. There's some ideas on there based off that. So something personal, something you're interested in. But again, I intentionally left off video game characters because that would be representing a virtual thing virtually. I want you to represent a real thing virtually. But really, if you have some ideas or whatever your hobbies or interests, something you know really well, was my thought. But if there's something you want to know and want to go do research on something, feel free to learn more. More is always acceptable in my class, but just run the idea by me and we'll talk about it and stuff. But some real world object, make a Java class to represent that. So the homework's not due for a couple weeks, but I would ask that you go ahead and do this one, knock this one out this weekend or in our lab time tonight and get some practice before we move on to the other parts of object-oriented programming. Okay, so there's the first thing on the list. Check that out. And for the next thing, I had it planned where we go into our example the other night. So instead of waiting till later in today's example, I'm just going to throw it in the example from the other night. If you also have that on your computer, if not, we'll throw another one in we'll get to our example later. That's the right one that flipped over there. Oh yeah, object example. So here's the stuff from the other day. Just a quick recap. We created this animal object and our rough context for it to help visualize things was maybe like a vet office. What does the vet need to know when the patients are coming in? Probably a lot more than this, but that's the starting point. What's the animal's name? How old is it? How much does it weigh? And then that Boolean, is it just there for a checkup or is it an emergency situation? Because most animals are just going to be there for a checkup. If the word emergence, that's one of those things you kind of have to evaluate. We could have gone either way, right? We could have made the Boolean called emergency. And then when it's true, it rushes to the top. But if we put the word emergency all over our software, that might start to look a little funny, right? And we don't want to say checkups aren't emergencies. Because maybe it's not like rush into surgery emergency, but an unplanned checkup was scheduled because something's definitely wrong. So you want to think about things like that and how certain words are going to affect the rest of the software when you see them, things like that. And that's what that first assignment is, looking for the words and what data is needed to represent that. The methods that we use for it. Then we looked at inheritance, all these other things that extended that class, created a subclass, which was some words I forgot to write on the board the other day. Vocabulary term sort of things that show up in multiple choice quizzes. And again, to get certified as a Java programmer, you don't write Java programs. You answer multiple choice questions about the Java programming language. So there's multiple terms we use for the layers of classes in inheritance. We might say a superclass, and then everything in the superclass is going to be inherited by a subclass. We might also say parent class, and everything from that parent class is going to be inherited by a child class. You'll have probably already heard all these words before. I just wanted to make sure and explicitly state them. Review is good for the learning process. We also might use the words base class and derived class. So we inherit everything and derive a new class from this base. That one's not used in English as much, but if you end up on an international team, that might be one that fits in their language a lot better. Fits in their language as nicely as parent and child does in English. Right? There's some subtle differences in the way we communicate and speak. So you will see all three terms, and they come in pairs. A subclass inherits from a superclass, or with polymorphism, a subclass can always behave as its superclass. Child inherits from parent, so that one goes really nice in the European American culture because that word fits nicely. And a child can always behave. A child class can behave as its parent class. Likewise, a derived class inherits everything from a base class, and through polymorphism, a derived class can behave as if it was the base class. You'll see all three sets, but what we don't do is we don't mix and match. We usually don't say superclass and child class together because we keep the pairs together. It's I guess the thing you might want to look for on trick answers on multiple choice quizzes. There'll be a couple that look like right answers, but one of the ones that looks like a right answer might have a mix of the pairs. So they do stick with the pairs. We have to write those words up there. And then the other thing that I forgot to put in there, which it's going to go in tonight's example again as well, but it's one that might as well single out. It fits, the description of it fits very nicely in the vet office thing. Because there's another important thing that veterinarian office context might want to know. That's how many animals are there. We want an overall count of how many animals there are. Well, each class is its own, each class is different. Then when we instantiate that, there's even more differences, right? I think in our main, where's the main? Yeah, in our main, we've made at least 2 lions. So we can create uniquely different things. So, well, if we wanted a counter, we'd have to come over here and keep track of all these different things, a bunch of complex stuff to do it. But another way we can do that is back to that keyword that we've seen a few times, static. That means there's one and only one copy. So if in our parent class over here, if we put the counter here, right, at first just a private counter. Oops. Let me erase that. A private integer called animal counter. We could go ahead and initialize it. So up here, outside of any methods, we can also do that initial assign. That's as far as we can go with anything. We can declare stuff, and we can say what the default value is. Most of the time, it's better not to do the default value there. We want to wait until we're inside of a constructor to put the default values, but for small things, simple things, strings that you know it's always going to be that. The ones that are essentially constants, it's okay to go ahead and put that value there. Or things like a counter, we know we're going to start our counter at 0. So it's okay to do that some, doesn't cause a problem, but it's better to wait until we're inside of a method like a constructor to do that. So this is just a counter. Our animal class could have it. Every animal we create would have its own new counter, all that stuff. But if we throw that keyword in here, so instead of a private integer, we had a private static integer, now there's going to be one and only one copy of that. There's only ever going to be one copy of that. And if there can only be one copy, we can use the one on the blueprint, the design, the class definition right here. We don't have to make another counter. So now, no matter how many instances of animal we create, how many subclasses or anything, they're all going to share that same counter. I think I said that right. Let's run this and see what happens. So to keep track of that counter, we don't want to, that's something we're never really going to do anything manually with, right? It's the computer is going to automatically track that counter. So in all of our constructors, I'm just going to increment it by 1 in every constructor we have. Because we'll have that everywhere. So look at one of those constructors that made us create this empty one that doesn't do anything. And it made us create this one that had the same parameters as the parent. And then it just passed all those parameters up. Any thoughts? Do we need to increment the counter here as well? Or is your thought just, let's run it and see? That's the way, that's the best, that's what we normally do, right? Let's run it and see what happens. So, well, it's a private data field, so we better create a method, one of our getters to access it. We're never going to manually set that. That's something that the computer's handling that counter. So if I do Alt Insert, I just need a getter for the only one that's not there already. That way we have that nice little following the syntax. We're talking about that some tonight. It's the rough plan on the rough schedule for tonight. But a method that will return the value of that counter. And then our code is very consistent because we're not sometimes accessing methods and sometimes accessing data fields directly. We're doing the same thing everywhere. Consistency goes a long way. So that's one of the things built into the idea behind Java. Oh, this is something different. I started to type ahead. So right now we have lions objects and gorilla objects, cat objects. But we don't have any actual animals. And the thing with the static variables, we saw this very briefly, is we don't need an instance to get to the static stuff. Our static stuff we can get directly from the class. So to do that, instead of creating an instance, we'll go right to that static class. Oh, yeah. Notice that since it was a static data field, it made that a static method. The rest of them are just public methods. So actually, it's not even on there. If we look at something that inherited from that, like we have a lion, or there's a dog there. So D1 dot, you notice get counter is not even on here because D1 is not a static object. D1 is a particular instance. So to get to our static stuff, we need the class name, animal, and there we have our static method, get animal counter. So basically the idea is that everything's going to share that counter. You see, it definitely counted something. We don't have any animal objects, but from all those child classes, they inherited that. So they share that same counter. So every time one is created, our counter goes up by one more. That is often a very important aspect of object-oriented programming that always runs in the background. We almost never do anything except read that counter. Does that make sense? See how a place to use our static data fields, our static over here, means every single instance shares the same one. So let's make one more object. Let's make another dog. So that's here at the end, and I can just look a couple lines ahead and not have to try to think back about what I was doing 3 days ago to create a new instance of it. So dog needs a name. Rex, that sounds like a good dog's name. Rex sounds like an old dog. Maybe he's like 9 years old and 21 pounds. Just a routine checkup. Oh, wait, that's not what checkup was. Whatever that first one was. I guess I have to look back at. What is checkup? Yeah, so true, it's just a routine checkup. And true, Rick wears a bandana. I think that was the order those went in. We don't even need to do anything with it because we want to see the other thing. So we print that out. It's still counting that. So now we have six animals. So keeping those counters running is an important thing. Any questions about that before we move on to the next thing? Or some of you might have already guessed that I'm going to point at that again very quickly as we move on to the next thing. We'll create another Java project. I'll choose an ant one this time. At some point in time, I'm probably going to create a Maven project just to point at a file there. But we'll get there in a few minutes. I'll create a new one, and notice in the name, we've seen that a few times, right? I've deleted all the previous examples. Once I put those on GitHub, I delete them from both of them. But it knows that we're up to the 17th Java project. There's a static counter running there. So every time we create a new project, that static counter is going to increment by 1. Something that shows up all over the place. So your auto incrementing IDs are going to be static counters, right? If you start putting stuff in the database, you'll probably saw this in SQL class. We start putting things in table, item 1, item 2, item 3. It's like, whoops, there was a typo, delete item 3, put in the next one, and it's on item 4. Your auto incrementing is already past 3. So it keeps going after that. Those are static counters. Very important thing. So we want to be familiar with using those. What are we on? Object example 2. Versus this one is a manual counter. I'm just looking right over here at the project from the other day. It's okay, that was example 1. Example 2 takes a lot more thought on our part. Computers are pretty good at running accumulators. I'm going to delete all these comments, get them out of the way, and actually come back and put them in, because there's still another line on Java docs we didn't look at last time, so we'll look at that tonight. I'm in a car object tonight. That's one of our standard examples. So let's diagram out what we're going to do. Everybody's familiar with UML, right? Unified Modeling Language. International Standard Communication. I guess it doesn't take long to summarize it. We live in a global world, but not all humans speak the same language. So we need a way to communicate across those language barriers with technology. So there is a standard for that, Unified Modeling Language. It's a vectorial-based language. Everybody same in the world, people studying this in China or read that tonight, or I guess it's early morning in China, people getting ready for class in China. People in Europe that just finished studying it. Students over on the West Coast, they're going to be doing it in a couple hours later this evening. We're all learning in South America, because they would speak a different language. We all learn that same pictorial standard of communication to bypass those language barriers. It goes across all of IT, but some fields of IT do a lot more international communication than others. And software development is definitely one that does a lot more international communication than others. There's a pretty good chance you'll end up working on a project with people that don't speak the same languages, because software is needed worldwide. So software developers get hired to work on projects. You might be the American liaison on a project filled with 10 developers that all speak a different language, and the project developer had to hire 3 or 4 translators just to struggle to keep the group together, that sort of thing. So a lot more international communication in our field. So there's standard pictures for doing this. Our UML diagrams look like rectangles. So right off the top, everything in Java inherits from this class called object. It's built in, there's a few things there. What do we have? ToString, clone, equals, finalizer, and hash code. The finalizer is going to be deprecated very soon. So right now, if you type it in most of your IDEs, it'll cross it off. It'll still compile and run, but it uses strike-through text to indicate or to remind you to stop using that. But that was just something that was a message we sent to garbage collection. Improvements in garbage collection mean it's no longer necessary for us to send that message. So it cuts some of that out, because object-oriented programming is terribly inefficient. It's good for the human. And like always, what's good for the human is bad for the machine. So everything's going to inherit from that. If we don't say what we are the child class of, what class we are extending, it will automatically inherit from objects. So we always have those. And then when we extend that, the child class is going to get that stuff. So we will always have those methods coming down from there. So our UML diagrams, probably shouldn't draw the bottom of that box yet. Look like a big rectangle, and we have certain symbols we use in there. Up at the top is the name, the identifier of it, the class name. So we'll make something called car. Actually, car should probably be a subclass, right? Because car is one of our main categories. We have vehicles. That's a good name for it. So we have vehicle that has all those properties that both trucks and cars and vans would all share. That sounds like some good car, truck, and van will be down here. So some more in those planning stages. Remember we talked about that? I'm not going to do the full notes today, but it doesn't take long to jot those down. And then when you get to the great big projects where you do need that stuff jotted down, you know what to do. You don't have to figure it out when you actually need it. It will go very, very quickly in these easy situations. So what data fields do we need? Well, we're going to have a make and model and year. Make, model, year. Everything is going to have that. Number of doors is going to be down in the subcategory. Isn't it? Number of doors we don't need to really worry about till we get down to 4-door, 2-door, or 3-door, I guess. Might be a good summary on that. Probably want to include a method in here, so I'll go ahead and put an accelerate and decelerate method. So we'll need a speed so that we can change it. That's probably good for the syntax example, right? Gives a couple methods, some things to work with. So once we have our data fields, we might as well do a counter. Whoops, I left a part off. We're in Java, so we do need to type. Make and model are going to be strings for sure, right? Say Toyota Camry, there's not a number anywhere in that. Dodge Caravan, there's no numbers involved in the make and model. Which I should write this properly. Type first on the data fields. So a minus sign indicates they're private and a plus sign for public. So minus a private string called make, a string called model, what about year? What type of data should we use for year? Oh, I didn't see that. Where was it manufactured? That's a good one. So we'll add that in. And that's going to be a string as well, right? I'm going to put the counter last, so I'll put that down here. A string. Plant would probably work for that, right? Which plant was it manufactured at? Because that's in the chat room, the place where the car was manufactured, right? Recalls aren't, for example, a recall on for Toyota cars aren't going to apply to every Toyota. It might be Toyota's recalled from the Georgetown plant, or it might be Toyota's recalled from, I think there's a plant in Virginia. I don't know where all the, I mean, I know where a couple of the local ones are, but the recalls might only apply to certain ones coming out of certain plants. So which plant was it manufactured at? Or we're in Java, we should spell that out. Manufacturing plant. Stick with those nice Java conventions of spelling it out. It's a lot on the board, but typing is easy. And we only have to type it once. Because now if we type an MA, it's going to be right at the top of the predicted text list. We really only have to type it once. What about you? So the question we want to ask is, can we do math with it? Like a zip code or a phone number? They're all digits, but two zip codes added together don't mean anything, right? With Excellersburg zip code 47172 and add it to Clarksville zip code 47129. A couple towns here locally for those who live elsewhere in the state. If we add or subtract or multiply or do anything with those numbers, it doesn't mean anything. So zip codes would be a string. Same thing with phone numbers. You can't add two phone numbers together and figure out somebody else's phone number. Or in the case of those two that I just erased, if we did any math with them, we'd be in the wrong state. Because 47 represents Indiana, or at least the southeastern corner of Indiana. At the very least, we'd be in the wrong corner of the state. But a year, we might do math with that. We might want to know how much newer or older two cars are. So integer, a private integer year. Speed, we're going to do some math with for sure, right? And I'm going to go ahead and do double for that. Depending on how our time goes, when we do our accelerate and decelerate method, it might just be a random number. And put two cars like they're racing and then run them through some random stuff. And then finally, a private static int car counter. And then for our diagram, I guess finishing up the parts I want to talk about, we would set up our methods. The key thing that's missing before we get to our example is a plus sign means public. So when we have public things, put in the plus sign, and then we'll have our method called accelerate, which is not going to return anything, right? Accelerate method will change our speed value. So it's not going to, it doesn't need to return a value when it's done. It just changes that value internally. Accelerate probably doesn't need any parameters in this case, but we would list those out in, if we needed them, list it all out there. And then a colon, and then we list the return type. Void is a type. We talk about it as nothing, and we think about it as nothing being there, but it's kind of like the space is for us, right? Y'all have already seen that as a space isn't really nothing as far as putting strings together for a computer. We need that in there. Same thing for a void. A void is not nothing for a computer. We think about it as nothing, it's not returning anything, but there is something there. And when we get up to asynchronous parallel programming in a couple weeks, then we will more explicitly have to use void as a type, because we have to have it coming and going. So our others, car will probably need to extend that some, right? What else would car? Car would need number of doors. So a private integer called doors, or I'll spell it out. Number of doors. Is trunk or hatchback maybe an option there? We don't see hatchbacks as much as we used to, mostly all trunk. We see really small trunks, but that gives us a Boolean option. It's either a trunk or a hatchback. And as I stop and think about that for a second, I think it makes more sense to have hatchback as the word. Then when we look at our code, we'll see is hatchback. If that's false, we know we have a trunk. Does that make sense to everybody? Anybody have an argument against that? Because we all think a little bit differently, right? So I'm thinking a Boolean, call it hatchback. And if it's false, we have a trunk. If it's true, we have a hatchback. I guess realistically, there'd be different situations. That's probably good for what's still continuing syntax examples and things we can work with. Trucks are a little bit different. Trucks have that big bed. Extended cabs, that might be important, right? So I'm thinking private Boolean for if we have an extended cab or not. So instead of a direct integer to say how many doors it is, just a Boolean, and if it's a regular truck, so extended is false, then we have 2 doors. An extended cab probably we'll count those as 4 doors. I know they come in different sizes, but just a quick example for tonight. But then the truck has the big bed for carrying things. Those are usually measured in tonnage, right? Half-ton bed, half-ton truck, full-ton truck. Is that something we're going to do math with? If we need to haul a load of rocks, would we need to compare that value on 2 trucks? So yeah, I think we'd do some math with that. So it's not going to be a string. And half ton is a common size, so an integer isn't going to work for us either. So double tonnage. Um, 4x4. Should 4x4 be the default, or two-wheel drive be the default? I guess there would be more types. Really, we would probably have an enum, and enums are on the list for next Tuesday. I'll do it as a Boolean. Boolean. 4x4. That's probably good there. Just to finish out writing on the board part. And then we go through and think about the same things for the van. So you're gonna want to, this is what you're gonna want to do for that first project. Think about real world objects and categorize them with the some subclasses too. I think I put that in the instructions. We don't want just a single class. You want a parent and some subclasses. So what's something on that list? Can't remember what else on the list. So like maybe with musical instruments. The one that's on my mind, I just ordered a new trombone recently. It's on back order. I've been waiting forever for it. But a Superbone one that has the slide and valves. So there's different types of trombones. So a trombone object would have a lot of that basic stuff. The material, is it brass or silver? The bore size, the angle on the bell, a bunch of data points about it to describe it. But then there's more than one type. Does it have the F key? Does it have valves? Does it have a slide and valve? Different subtypes of trombones. So you'll want to come up with some of those and try to categorize the details. So really the assignment is mostly this part. So once you get to the thinking, but you're going to turn it into Java code. It's just a lot more thinking involved in it. A van, I guess we're probably most interested in square footage. Both work vans or minivans. That's what people care about. When you take the seats out of a minivan, how much square foot do you have? Square footage do you have to haul stuff? Which is, again, something we might want to do math with to decide on whose minivan to hold the seats out of and pack up for the family vacation, or at the family reunion, whose minivan gets the seats pulled out so that everybody can head down to the lake or something as a group. So we can have fractions, so square footage. And there's a lot more things we could think about, right? We start listening now. We haven't even mentioned engines yet. Actually, I'm going to take the speed off. Let's just do a data object. We'll come back and look at the doing stuff. I'm going to take the speed and accelerate method out there because now we just have data. Like this could go on a retail site, a used car dealer's website. These are the things he's going to want people to know about. And we want things to represent them. So every time a new vehicle comes in, this is what goes in the database. So if people start coming in with questions, contact the chatbot per se. We set up a chatbot so that people can jump on that website round the clock. Well, that chatbot's not a human. Can't read that off the paper. The chatbot needs it in object-oriented form. There's a good chance the chatbot's going to be written in Java as well. We see those in Python some, but Python's a slower language. On something big and complex like a chatbot, that slower still shows up, and people notice the delay. You all have probably encountered that by now in our modern world, right? You notice some chatbots are quicker than others. like noticeably quicker. That's the reason it took Python so long to take off. Some of you younger people, most of what you remember about computers, Python had already taken off because the machines were quick enough to handle it in most situations. But in some complex chat rooms, people try to do their chatbots with Python and the speed, and it's showing up again, that difference compared to chatbots written in Java. So this is something the chatbot would know. Be like, oh, follow the little message box when somebody goes to the website, can I help you? What are you looking for? I need a 3/4 ton truck in red. Oh, color. That's important. For some people, they don't know much at all about cars, but they know what color they like. Like, I don't care what color, I don't care what kind of color it is, as long as it's blue or yellow. I make yellow cars because they're easy to see. Less likely to have people pull out in front of you if you're in a yellow car. So most people that you see driving around in yellow cars have had that experience of somebody pulling out in front of them and they should have been able to see it. Like that trend over the last 10 years to make cars the same color as asphalt. That just seems like an awful idea to me. It's like it's going to blend perfectly into the background. People are going to pull out in front of it all the time. But what color is it? That is a data type in Java. I don't think, do we need to import anything? I was using hex color. Hex color will work. Which is technically 3 integers, but we give it as a string, right? Does everybody see hex coloring? The one where 6 hexadecimal digits that we usually see it on websites and stuff. That is the direct control over the pixels. It's hard to predict things compared to some of our other color options like HSV. But where we're actually sending a particular number of ons and offs, or a sequence of ons and offs to every pixel on the screen. It's actually 3 integers, but we often treat it as a string. It's easier to deal with that way. It's easier to type that way, and the computer can easily translate it into an integer. So I'll just set that up as a string because every one of these is going to have a color. Okay, now we're pure data. This stuff's going to be in the database. We can retrieve it, do stuff with it, and that'll also work very, very nicely for the point about means that I wanted to make and hopefully get you to make. We could probably come up with a lot more data because that context makes sense. A chatbot, anybody that works for the car dealerships can know this. If somebody comes on the website at 2 in the morning, you want that chatbot to be helpful for them. You want the chatbot to leave them helpful and be knowledgeable about all the vehicles at that car lot. So we need to put some data objects together for that chatbot to work. And once the thinking's done, the typing's easy. Right? Actually, we saw the other day, after we type this part, we're pretty much going to hit Control or Alt Insert for everything on NetBeans. Control Alt Insert if we're on Eclipse. But any major IDE is going to have that auto text. So we'll mostly hit Alt Insert. So we'll create our new class. And the parent of everything is going to be vehicle. Get rid of this stuff. So I'm going to put more Java docs in it later. Well, let's go through this really quick now that we've got this, using predictive text as much as possible. So first thing we need is a private string to represent the make of the car. Private string for the model, private integer for the year, since we might do math with that. A private string to say what color it is, or categories of colors. Yeah, actually, this one will work really, really well. We'll extend this one next Tuesday when we look at evenings. Because we don't have an infinite number of colors cars coming, right? There's a short list. So when we look at short list of options, we'll see that. A private string for manufacturing plant. That one shows up a lot on like Carfax. So that's what we need to know if there's recalls. Or some of the information we need to know if there's recalls. And we probably want to know how many vehicles there are. So we'll want a private static integer vehicle counter. That's our main data fields. That's what everything's going to have. And then that static integer, everything's going to share. So we need a constructor. So alt insert and generate our constructors. And really, the default constructor, the one that doesn't take in any parameters, the compiler will create that on its own. But it's a good idea to go ahead and do so. It's actually part of our conventions called beams, which are the yellow notes that I pulled out for after the break. So I'll go ahead and hit select none and do the default constructor, the empty constructor in no arg constructor. Label these curly braces so we don't get lost in them. In vehicle class. So after that constructor, we probably need some different constructors. In a chatbot situation, we probably want a lot of different combinations, right? Some people are going to ask that chatbot for a particular make and model, and they won't care what year it is. Like, do you have a Toyota Camry? We don't care what year. Or in particular, the reason that one always pops in my mind. There's different ways to look for good cars. One rule that I found I've come up with over the years that I really like to do when I look for a new car or go car shopping is when you start reading reviews, people are going to say lots of good things, right? And there's marketing departments to say that. What I like to look for is what do used car dealers give their daughters? If it's not sporty, that's probably the best used car on the market. If it's not a fancy car, fancy sports car, make their daughter happy, used car dealers or sons probably get whatever. But if you try to find out what used car dealers give their daughters, that is probably the best car in the market as far as reliability, low maintenance costs, upkeep, and like across the board. Because used car dealers know what the good car is, and that's what they're going to put their daughters in. So there's different things we might look for. Some people, so for the reason Camry's always in my mind, people might want a 1995 to 2002 Toyota Camry. And we still see lots and lots and lots of those all over the road because those are really, really good cars. They last forever. Those are cars that routinely pass 500,000 miles now. That it's been long enough to have driven that far. So some people might only want the year. I want to make sure it's within 5 years old. Nothing older than 5 years. Right? Anything on the lot will be good otherwise. So we want to put a bunch of different versions of constructors together. But that's easy when they're all generated, right? I'll insert. Let's do a constructor with the make and model. We know what type of car we want. Generate that. Alt insert a constructor. Some people might only care about the color. Like I just want a blue car or a black car. I want a gray car. I want something that blends in perfectly to the crowd. It's not going to make me stand out. Everybody's going to care about different things. I mentioned years, so maybe just a constructor with only the year. Somebody will be like, I want a car that nothing more than 3 years old, something fairly new. or nothing less than 10 years old. That way we look for budget concerns, really, right? At least 10 years old is probably in my budget, that sort of thing. So we'll want to think about all of those. I'm probably going to stop after the next one. Make, model, and year are probably the most common ones. But all the different combinations of our data fields, we might want constructors for each one of those. Or we might just do the empty constructor and do all of that with getters and setters afterwards. There's another one in this next set of notes that I have here, Java beans. Okay. The word beans sounds like it goes very important with that coffee theme of Java. And kind of does, and one of the conventions is all those constructors, we have to have at least the default constructor, and then all of our getters and setters. Data fields are kept private, written in camel case, minimum of default constructor, but then getters and setters for all of our data fields. So alt insert, do getters and setters. Well, actually select all of them except the counter. Well, actually I'll generate all of them because I don't want the setter for the counter, but it's probably easier to hit select all and to delete the one that I don't want. Generate that, and then we can just knock out the set vehicle counter so that a human doesn't need access to set the counter. And then those overrides that we saw the other day. I'll insert override methods, and cloning is a shallow copy. It still refers to the same spot in memory. It like gives us a different name for the object, temporary one. To look at and delete. So it's not a deep copy. It's not a completely separate thing. If we make changes, they change to the original. It's a shallow copy is the term for that. Equals and toString, we almost always wanted to do that. ToString, I'm just going to do a quick description. Y'all can make, it's not too difficult to change those. Oh, and that thing that I started doing earlier, labeling those closing curly braces, and I've kind of drifted away from it already. You can put that in your template. Okay. We're going to generate a lot of those getters and setters. So if you go over to tools and templates, in Java class, well, somewhere in here, you can see it's a really, really long list of templates, but somewhere in there is a template for the generated stuff. I think you can also get to it over here somewhere. Go to options and editor, code completion. Oh, code templates. So under the, if you go to options and editor, there's also a template for it here. If you look through here, I don't see any getters or setters. For loops. Well, here's just a regular method. So like, if you find the getters and setters on that long list, which just scrolling through the list, we don't need to waste our time doing it. Add that closing tag for the curly brace there. And then whenever you generate the code, you have your closing curly brace marked, which is really useful. So we do have control over that. And while I don't want to take a whole lot of fast time for that, much more than just pointing at the list and telling y'all we can do that, it is definitely worthwhile. It will definitely be worth your time to go into those templates and customize what you want in there. There's a good reason. It's almost, and we'll do that on every IDE, so it's almost like it's part of the language, part of learning the language, because you're going to want to do that. So a car, I guess you can say, I'll make an example that it's a red Ford F-150. That might be a good sentence. Okay, we don't need, we can get the details later, but just the quick general print is the short version. So a red Ford F-150, so that'll be the color. I wrote it all out as one string. So this time I'll go to string description. Starts as a new string. And then description. Concatenate assignment. So plus equals the color. This dot get color. And again, it was mentioned the other day, we could use the data field here, but for inheritance reasons, which we won't talk about until next week, when we actually see the error next week, it's better to use the method. So for now, I'll say use the method instead of the data field directly. But we're choosing them from the predictive text, so it's not difficult either way. So the color plus maybe a comma. Actually, one of the words needs to go into a sentence. So a yellow space. I'll copy that line. A yellow get make plus a space plus this dot get model. So like a yellow F-150, a yellow Ford F-150. That sounds like a good generic output, right? We can build up more specific ones if needed. Oh wait, we probably want year in there too, don't we? We want to know what year it is. I'll paste that in there and start with the year. Get year. Then there'd be a comma. So a 2019 yellow space Ford space F-150. That's like a good generic sentence. We can pop that into a full grammatically correct sentence easily. And then we can return that. So if I can spell it correctly, we can return it. Oh, because I spelled it wrong elsewhere. T's. What is it like that? Oh, I put that in the wrong spot. Sorry. That is what should go here. The two string. What? Missing return statement. Did I not make the color? Private string color. Make, model, year. There's a get color. Returns the color. Retype that line. Description, concatenate this. Get color. Plus a space. Does anybody see what it doesn't, what it's not liking there? It looks like it's public. Public string gig color. It returns everything. Okay. Apparently something was wrong. It got longer, so there was a thing missing. Y'all have probably encountered it before. I always like to specify it. The human brain has a tendency to fill in gaps. Has everybody heard about that before? Like we can all see our nose all the time. Just when we're young, we learn not to pay attention to it. That's why that got your nose joke. There is actually an age where that's funny because kids are just starting to not pay attention to their nose anymore. So they're used to seeing it. So if you do that joke, they'll be like, wait, there was something there. So there's a small age where that is actually funny and causes kids to panic when they first stop seeing that. Well, we fill in gaps. It's a way to avoid sensory overload. Sometimes our brain gets it wrong. And when you're coding, that's something that actually happens a lot. Your brain knows what is supposed to be written there. So it will just fill in that gap and you will actually see what is supposed to be there, even though it's throwing an error. So whenever you hit situations like that, the best thing to do is delete it and type it again. Although I chose something from the predictive text again, and apparently I chose the wrong thing from the predictive text, and it, when I copied and pasted, it finally worked. But I did not see an error there at all. So maybe when I go back and watch the video later, I'll realize what went wrong. So that gets our equals. Anybody have any thoughts on what would be good equals for a vehicle? Maybe make and model. We'll ignore year, but we'll say regardless of year, 2 Toyota Corollas are equal. So if, this is nice. So we need a vehicle object. Remember we saw the other day that when we override from that we inherited takes in any object. We don't know what it is, but in our case, we do know it needs to be a vehicle object. So really, this would be in a try-catch block. We haven't talked about those yet. We'll try to see if we can turn it into a vehicle, and then do something else if we can. But for now, we know we'll be okay doing that for tonight's example. We know we're going to have a vehicle object. I'll call it V2. Is take that object that was passed in and cast it into a vehicle. And then if this dot get make, which is a string, and strings are objects, so strings already have this equals object built in. So whenever we're in strings, we're going to say dot equals v2 dot get make. So a bunch of parentheses there. But does that, everybody see what that's doing? Equal will only work if they're stored in the same spot in memory. Which in most cases that's okay, but not all cases. And there's a brief delay where it is definitely not okay because garbage collection won't have noticed a duplicate and put them in the same spot. So if you happen to be in that brief delay, it's going to miss it because garbage collection hasn't cleaned it up and put it in the same spot. So it will always be better to use the dot equals method than equal. Garbage collection is really, really good. So it's only a few milliseconds, but on a modern computer, a lot of stuff's going to happen in a few milliseconds, right? A few milliseconds. When we start taking measurements, we're going to measure in nanoseconds. So milliseconds are thousands of our measurements. So if the make is equal, whoops. And this dot get model which again is a string, so we can use dot equals v2 dot get model, which I was typing that with it behind the thing. Did I get the parentheses right? I think so. So we close that off and put in our curly braces, and if they're equal, we'll return true. And if that clause is false, we return false. There's kind of a redundancy there, right? We're just returning what that statement is. So instead of doing the whole block, why don't we just return that? I apparently accidentally deleted some closing curly braces. Put those back in. So in vehicle class, in equals method, and putting those labels in the template can be really nice. Oh, because it's not returning yet. So instead of doing that selection structure and basically just returning what it is, I'm going to semicolon over here and just return that all together. Because then if they're the same, it's true. If they're false, they're different. So one place to kind of clean up the code, I guess, a little. And obviously that thing we did on the line previous could have been done in one line. If you're the type of person that likes to type the one big long line versions of things. I was hoping to be done with this 3 minutes from now, and there's 2 more things I want to do here. So I got our equal, but that's not our only normal comparison. We also regularly do bigger or smaller, right? For that, we need an interface, and those are still ahead. So jumping ahead a little bit, the short version of it is an interface is kind of the starting point is it's a set of rules we have to follow. Certain things we agree to meet. There's actually 2 that I'm going to implement. One of them is very, very common. In order to write things to a file, they have to be serializable. So there is an interface that we often want to use if we're going to ever write this object or any of its child objects, because the child objects will inherit those following the same rules. We'll talk about them in detail, but along with extending stuff, we can implement interfaces. And I guess it's kind of a preview mode at this point, but there's some pre-built sets of rules that we're agreeing to follow. And really, once we've talked about them, we'll talk about enforcing those rules. Is something we want to do, even if it's our own code, some verification. But one of those is very common, serializable. We have to implement serializable in order to write things to implements. I forgot an S. We need to implement serializable so that we can write this data to a file. That's something we're going to look at here before long. serializable. So serialize is like serial communication. We have to be able to take whatever form this object is in our code and turn that into one long string, one long line of 1s and 0s. Kind of like serial communication. We have to be able to turn it into just like a line of 1s and 0s that goes down that can be sent down a single wire in order. We have to follow some rules in order to do that. Which we'll come back and talk about the rules we have to follow there, because that's actually a blank file. But if we don't say we're following the rules listed out in a blank file, so there's no actual rules there, some background stuff doesn't work. We'll come back and look at that later. And again, we need to import it. So it's in the java.io package. Another one that we'll often want to implement is comparable. Is that the one I want? there are several. I know I use comparator more often. Yeah, comparable. There's also a comparator. I use that a little more often, but comparable is a better starting point. I have an example pulled up. I have an example pulled up on my other computer, so I don't drift off too far. But those are two very common things. But notice when we brought in comparable, well, it's not asking us to import anything, otherwise comparable would be underlined. But it underlined our class name. And the comparable object, it made our vehicle object abstract. And we're going to spend some time talking about abstraction and interfaces. But currently, those rules are in comparable. There's a rule that says anything that implements this interface must have a method called compare to. But we don't have a method called compare to. So it says, well, vehicle doesn't follow the rules, so we can't create an instance of it. It's abstract. We can't make a concrete object out of this. So we would either need to actually explicitly state that it's abstract or implement that. If I click over here on the little light bulb, you'll notice the first suggestion is implement the abstract methods. Just control shift something. I'm drawing a blank on what the other one is. I have to Google. There's too many different IDEs, the keyboard shortcuts running together, but to implement abstract methods, control shift something. I'll look that up when we take a break in a moment. But now we scroll way down to the bottom of our object. It created this other method, compare to object. I'm thinking year is probably a good one to compare. Greater or less than, we will just say, look at the years. Which one's newer? Which one's older? Are they the same year? And notice what it returns, an integer. So 0 is equal. Well, this is the actual, like what the computer's doing. To compare, we subtract. If we get the same number, they're equal. Or subtract the same number, we get a 0, so they're equal. If we get something positive, the first one was bigger. And if we get something negative, the second one was bigger. So really we want to return something positive, a 0, or something negative. A lot of people just do a positive one, negative one, or 0. Just the 3 cases. But it can also be useful to return that difference, right? Year is an integer, so we can subtract it and actually return that difference. Well, again, compare to return this dot get year minus O, which O is not a very good variable name, so I'm going to switch that to object. That the predictive text template clearly wasn't written as by the same person who wrote the predictive text template above it. Right? More than one person have done this, and we're allowed to change this part. Right? That's just a reference. We can change that to whatever's useful for us. We cannot change the type. It has to be that type to override. So object.getYear, and then we'll just return that number and deal with it there. Oh, except object doesn't have a get year. It has to be a vehicle to have a get year. So if we cast that into a vehicle and then wrap all of this in parentheses so that it turns into a vehicle and then calls the method. And then if we want to know greater than or less than, we just check and see where that number falls. Is that 0? Is it positive? Is it negative? What number do we get when we say compare to? Okay, that went 5 minutes longer than I was intending. Then we'll do the subclasses and stuff afterwards. But does anybody have any questions about that stuff? Most of it hopefully seems familiar. I guess compare to is new. Those interfaces, that's preview. We're going to talk about that soon. But it's for preview mode, it's a set of rules we have to follow. There were no extra rules for serializable. We just agreed that our object is going to be serializable. There's nothing preventing it. Yeah, well, I guess ultimately the rule for serializable is we're not running any parallel processing. All right, so we can't take parallel processing and turn that into one solid line, one long stream of ones and zeros, because things are split apart. So that's pretty much our rule, and it's not even that much of a rule, because if we had that, some really, really good programmers built it into the Java language, Java virtual machine to fix that before we write it to a file. So it's even not even really that much of a rule, but if you just to have something there, we agree that this object can be serialized. It can travel down serial communication lines and go to a file. In comparator, we had to write this method, which you'll see. You can almost think of it as we inherited, when we implemented those interfaces, we inherited that method. But there wasn't anything in that method beforehand. Equals, it is different in the equals and toString, there were default values there. Kind of useless ones, both of them are just what spot in memory it's stored at. Not very useful for us in most situations, but on compare to, there was nothing there beforehand. It was just, the interface only had the method header and said, somebody will implement this if they want to, just that rule. Otherwise, it was stuff we saw the other day, and you'll notice that, oh, 100 lines, that's a nice number. 100 lines of code, and we didn't type very many at all. We mostly hit control, or we mostly hit alt insert a bunch of times. Yeah, that went a couple minutes longer than I was thinking. Probably a good time for a break. Does 10 minutes sound good? I see head nods in the classroom here. Rather than Zoom call agree. So 7:23, we will get back to it at 7:33.